Don't you put a 1 in the fraction line over it?
Dictate and I'll write it.
1 fraction line, and then 3 with a positive exponent of 2.
Very
plus
good.
3 with a positive exponent of 1. Wait, no, did I do that wrong?
Yes?
I guess 1.
Ah. They are not connected, right?
Right.
So you have to worry about this first. Then you have to worry about this. And now, how do I continue? What is this exactly?
That's 1 over 9 plus 1 over 3, which is 4 nines. Oh, I should have, yeah, right?
What is the least common denominator? You're right, but I need to show it. You're right, it's 4 9. The least common denominator is? Very good. Does this one need anything at the top? No. Or 1. Does this one need anything at the top? Exactly. So then 1 plus 3. 1 plus 3 equals 4 9. Careful with that type of problem. Okay. So let's look at 46. All these are on page 351. -5 x to the 4th y to the 5th over 15 x to the 4th y squared. Good. This is basically exponential rules. There is nothing here. I will definitely simplify. Here's how I recommend you do it. 5 divided by 5 is 1. 15 divided by 5 is 3. Both these two are the same quantity, 1 and 1. So I have -1 over 3. And now I worry about this. Copy the base. And what happens to the exponents?
You have 3?
Yes. From the exponent of the numerator, I subtract the exponent of the denominator, so indeed it's 3. This is it. $53. Any questions? Stop me anytime. 4 squared, z to -3, everything divided by 4 to the 3rd times z to -5. I notice there are 2 factors involved here. Both are present in the denominator and the numerator. The same thing with z. So I copy the base for 4. And what happens to the exponents? From power 2, I subtract power 3. And what do I get when I do that? Very good. Awesome. Times z, I copy the base. And what happens to the exponents? Yes. From -3, I subtract -5. +2. Because it's -3 plus 5, which is +2. Which of these 2 factors will go to the denominator? One of them will not, and I cannot move it. But the other one will go to the denominator. Which one will go to the denominator? Yes, very good. So this is z squared over 4. Awesome. Very good. Well done.
So I'm guessing in that last problem, the reason why we didn't divide 4 by 4 was because they're not the same power. Something.
Exactly, I cannot. The exponential rule specifically says, copy, don't touch the base.
But had they been the same power, we would have divided in that case.
I would have done the same thing as I did with x to the 4th and x to the 4th.
Right. Okay. All right.
I didn't even apply an exponential rule. They are the same, 1. But yes, I can apply the exponential rule, and I will say x to 4 minus 4, x to 0, assuming x is not 0, is 1. Very good. 51.
So whenever
Yes?
they have the, I'm sorry, so whenever they have the same number,
I'm using the exponential rules. Copy the base. Yes. Yes. So 51. X to negative 2 and y to the 4th divided by x to the 3rd, y to the 7th, and everything squared. I don't think you can read it. I'm sorry, it's negative 2 here. 374. Okay, so x to negative 2, y to the 4th, over x cubed, y to the 7th, and everything squared. Okay. Where do I start?
X. Start with X.
Yes, I see a quantity squared, and as long as I can simplify inside, I will simplify inside first. Okay, I see x and x so that I can use an exponential rule. I divide two exponential rules with the same base, two exponential expressions with the same base. Same thing here. When I'm done simplifying, then I'll worry about that. So then I copy x, and then what happens to the exponents? So x raised to which power?
is that negative 2?
Yes,
Negative 2 plus 3.
but is it plus 3?
Minus.
Aha. So x raised to?
Minus 9.
Very good. Multiplied by y raised to which power?
3.
Negative 3.
Oh,
Everything squared. Another exponential rule that we talked about last time. But now it involves negative exponents. So what? It's the same rule. Copy the base. What happens to the exponents?
Multiplier.
Correct. So what is the power?
Negative 0.5.
negative 5.2 is negative 10.
Good.
Negative 10.
Good. Multiplied by y raised to which power?
Negative 6.
Which of these two factors goes to the denominator?
Both
Exactly. 1 over?
x,
Yes?
10,
Very good.
y,
Yes?
6.
That's it. Awesome. Well done. Okay, let's look at 63. Any questions? Please stop me.
So the negative also to the
If it's in the numerator, it goes to the denominator. If it's in a denominator, it goes to the numerator with a positive exponent. Bless you. 63. Negative 2, x, y to negative 3. Everything to negative 3. How many negative 3's are there? Okay, x, y to negative 1, everything to negative 1. Okay, let's copy it. After this problem, unless you want me to look at or work on more problems like this, I would like to present the division of polynomials and then come back to this tomorrow because I would like to finish the chapter today. And then we'll come back to more problems like this, if that's okay with you. Because at least 2 students are waiting impatiently. I'm kidding. To see the long division. Okay, I'm kidding. Okay, what is the first step? What do I do first here? What I would like is to simplify this x to this x.
Yeah. That will be
You can't do that.
Of course not. You should throw tomatoes at me by even saying it, right? It's the power that I have to worry about first. I can't do anything inside. This is a totally different situation than the previous one. Here I had no choice. I had to simplify because everything was inside parentheses and squared. I had to do that. Here I can't touch. I cannot touch x and x till I'm done with their corresponding exponents. Very good. Equals. How many factors we see inside the first, the top parenthesis? How many factors?
3.
Yes, negative 2x, and you could even say negative 1, 2x, and y to negative 3. But it's good enough. It's perfect. Negative 2x and y to negative 3. How many factors I have to raise to negative 3?
3.
Correct. So negative 2 raised to negative 3. That has to wait. Then multiplied by x raised to,
Negative 3.
perfect, times y raised to,
Positive.
yes, positive 9. Awesome. Bless you. Good. Now the denominator. X to which power?
Negative.
Awesome. Times y to which power?
Positive 1.
Awesome. Good. Nothing tricky here. Good. So these will be dealt with together. These will be dealt with together. Let's start with this one first. Negative 2 raised to negative 3. What does that mean? Where does it go?
That is negative 2 times negative 2 times negative 2. No.
The power is negative 3.
Oh.
That would have been correct if negative 2 were raised to power 3.
That goes on the bottom.
Yes, so it's 1 over. Awesome. What do I have now?
Negative 2 to the third.
Exactly. And now it has to wait for the next step. But that's the next step. That's what I have to write first, but it has to wait right now. Negative 2 to negative 3 is 1 over negative 2 to the third. Times x to which power, please?
Negative second.
Yes, you're right. Negative 3 minus negative 1, which is plus 1. Indeed. That's power negative 2. Multiplied by y to which power? Very good. Awesome. Which of these two factors goes to the bottom? And which one I cannot touch and it has to stay at the top?
Doesn't the y stand out?
Yes, y to the 8th will stay at the top. Where does x to negative 2 go?
To the 1.
Very good. And now it's time for me to analyze this. Now, Ruby, you're right. Negative 2 times negative 2 times negative 2. Or better say,
Positive.
it's negative because it's 3 negatives to the third, right? 3 negatives. Negative 2 times negative 2 times negative 2.
Yes, it's negative.
So what do I write? Negative 8. Good. Now remember, when I have a positive at the top and a negative at the bottom, I have to rewrite it with minus in front. So this is y to the 8th over 8x squared. Okay, we will work more on these problems. Do you need another one right now? I can choose another one. Or look at division of polynomials and then come back with more. We'll have more of these problems for sure. Is that okay if I move on to,
Yes.
okay. So 5.6, division of polynomials. This is the last section of chapter 5. Ready? There are two different types. When we divide a polynomial, p of x, any polynomial, by a monomial, is one possibility. And when I divide by another polynomial, I'm going to say q of x. So this is polynomial, and these two are polynomials. Okay? So this situation cannot be solved like the way we are going to apply here. The method we are going to apply the method we are going to apply here is long division. And this is totally different. So I cannot use this method here, and I cannot use this method here. So let's try. This is a very simple situation. So let's quickly get it out of the way. So for example, x to the third plus x squared minus 4 divided by x. Is this a polynomial?
Is it trinomial?
Yes, it's a trinomial. It's a polynomial, correct? Yes. Is this a monomial?
Yes.
Just one term, one product. Only in this case, I'm allowed to split the fraction. One more time, how many terms we have at the top? In how many fractions can I split this whole fraction in? In how many?
3.
Exactly. So I'm going to write x to the third over x plus x squared over x and minus 4 over x. That's all I can do. And now I will simplify each fraction by itself. I know how to simplify this because I know exponential rules. X to the third divided by x is
X there. Wait.
X to the second.
very good. From the power of the numerator, I subtract the power of the denominator. Plus, the second one is the same exponential rule plus.
And 1.
Very good. Right? 2 minus 1. And the last one, there is nothing I can do about. And if you say, really, is this a real division? That's all I can do. There's nothing else I can do. And this happens only if the denominator is one term. Okay. Now what happens if it's anything else? So I'm going to pick a problem. Let's say problem 19 on page 358. 9x cubed, a cubed minus 3a squared minus 3a and plus 4 divided by 3a plus 2. Okay. Can I apply the method from before in this situation?
No.
No, because the denominator does not have one term. How many terms do I see in the denominator?
5.
In the numerator, I have how many terms?
4.
And then in the denominator, I have how many terms? 2. Very good. Before we start the algorithm, I would like you to bear with me and look at the following division. And yes, you will say, I'm not doing this by hand anymore. Okay, I completely agree. But let's assume that we are in the desert, in the middle of the desert, and we have to divide two numbers. We have no juice in our batteries. We have no phones. They just dumped us in the middle of the desert to perform a division. Okay? So let's say 5723 divided by 15. Why am I doing this? Not to torture you, but just to show you that this simple division of numbers is the same algorithm we apply here. Of course, here it's going to look very difficult and different because it has a variable. But it's the same idea. It's the same algorithm. So please bear with me for 1 minute. Here's how I ask myself. 15 goes into 57 because I cannot say into 5. So I have to group the next one, right? 15 goes into 57. How many times? Well, 3. I go back and I distribute. You say distribute. I'll explain why I say distribute. In a moment, you'll see why. I distribute 3 to 15. Well, it's 45. When I distribute or multiply 3 by 15, I get 45. But it's positive. But I have to change the sign because I will be subtracting. So 3 times 15 is not negative 45. It's positive 45. But I have to change the sign. I perform the operations I see, and I have 1, 2. I bring down the next in line. I'm asking myself, 15 goes into 122 how many times? 7. I go back with 7 and I distribute 7 to 15. 7 times 5 is 35 and 10. But 7 times 15 is not, it's positive 105, but I will have to subtract. It's not negative 105. So up here I put the positive or the number I need, but when I write it underneath, I change the sign. So this will be 17. Oh, then 8. Right? Am I correct? 0 and 4. Yes, yes. 0 and 4, 120, yes. So nothing, and nothing, and 2. I bring down the next in line, 3. And then this is a 1. I go back, I distribute the 1. 1 times 15 is 15. But I have to change the sign. And the answer is 7. How do I write the final simplified form of this? I divided 5723 by 15. What is the quotient?
7.
That's the remainder.
It does it.
Where is the quotient?
3/8.
Very good, 381. Plus, because the remainder is positive, plus 7 divided by?
50.
Exactly. So this is how we write the answer. Yes. So don't dump me in the desert. Okay, so quotient. Thank you. My apologies. And remainder. Divisor. In the same way, we're going to perform this division. Same idea. Very good. Ready? 2 questions before we start the division. Here's my first question. Is this polynomial in descending order of the powers of the variable?
Yes.
Is this polynomial in descending order of the powers of the variable? Question, what is the degree of the polynomial at the top?
3.
Good. Is degree 3 there? Is degree 2 there? Is degree 1 there? Is degree 0 there?
Yes.
So no missing term. Okay, I'll tell you what happens when there is a missing term. But in this case, there is no missing term. 9a to the third minus 3a squared minus 3a plus 4 divided by 3a plus 2. Notice that it's the same algorithm. The divisor is here, the polynomial from the top, same idea. Ready? What is your first question? What is our first question here? Here's our first question. 3a times what quantity is 9a cubed? You can write that on the side. 3a multiplied by what is 9a cubed? And the answer we put up here. What do I multiply 3a by to get that?
3a squared.
That's it. From the exponential rules, I know that that has to be 3a squared. Now remember, I used a word that does not belong in the division of numbers. I said distribute because I wanted you to be aware of the fact that now I have to distribute 3a squared to both terms in the divisor, not just one. So please give me the answer when you distribute to the first one.
Be 9a to the third.
But before I write under like terms, what do I have to do? Before I write under like terms, I have to change the sign. So it's going to be 9a cubed.
Minus 6a squared.
Yes. So 3a squared times 2 will be 6a squared, but I have to write under like term minus 6a squared. I perform the operations I see. These two go away. Perform the operations and tell me what to write.
Negative 9a squared.
Very good. Bring down the next in line. What is the question we ask ourselves next? 3a times, yes, times what if you want? 3a times what is negative 9a squared?
Negative 3a.
Very good. Notice that if this is power 2, this has to decrease to the next power, not increase. So now with negative 3a, I go to both terms and distribute. That's why I used the word distribute here, for you to understand what I'm trying to do. Okay, negative 3a times 3a.
Negative 9a squared.
But I have to change the sign before I write under like term. Negative 3a times positive 2.
Negative 6a.
But I have to change the sign before I write it. At the top, I don't lie. It has to be the correct quantity, the correct sign. But when I write underneath, I have to change to the opposite sign. Okay, so these two go away. What is left here? 6 apples minus 3 apples is 3 apples. Bring down the next in line. Now, I'm asking myself 3a multiplied by equals 3a.
1
Yes, sign.
plus.
Exactly. At the top, we don't lie. So now I go back with 1 and distribute. 1 times 3a. I have to change the sign. 1 times 2. I have to change the sign. These two go away. And now I can box this in. What do I box in? Careful.
Positive 2.
Good. So now we are ready to write the final answer. 9a cubed minus 3a squared minus 3a plus 4. Everything divided by 3a plus 2 is, please give me the quotient.
3a squared minus 3a plus 1 plus 2 over 3a plus 2.
I couldn't have said it better. Thank you. Any questions? Any questions? Any questions for me?
How did you get the
Say it again. This one?
Yeah.
3a multiplied by what is 3a.
Oh.
This completes, we have to practice division, of course, right now. But this completes our chapter 5. For some reason, the department said we don't have to do section 5.7. I can show you section 5.7, but I will not test you on it. It's up to you. But I'd rather stick with this and work on more problems. So the scientific notation, I'll talk about it. And everything else is done in chapter 5. So let's practice some more of division of polynomials. Okay. $53. Y cubed plus 3y squared plus 4, everything divided by y minus 2. Okay. Can I use the first type of division or this one that is called long division? Can I use the first one and split the fraction? No, because the denominator has 2 terms. Very good. Second question I asked myself. So then I have to use a long division. So second question I asked myself is, are the 2 polynomials in descending order? If they're not, they must be rearranged. Are they in descending order?
Yes.
Perfect. What is the degree? And that's my last question before I start the algorithm. What is the degree of the polynomial from the top?
3.
3. Does it have a term with degree 3? It has to, because otherwise it will not have degree 3. Does it have degree 2?
Mhm.
Does it have degree 1?
No.
No, it does not have a monomial in there with degree 1, so I will have to leave some room for that one. Does it have degree 0? Yes. Okay. So here's how we start. Y to the third plus 3y squared space plus 4 and divide by y minus 2. Ready? What is our first question? How do we think about this?
Why did you leave the space?
Very good. You know that we're going to put some terms here, right? And when I distribute one of those terms, I may get something with y. I cannot put it under this, I cannot put it under this, and I cannot put it under this. I have to put it under y, but I don't have a y. You'll see in a minute. Okay, so the question is now, y times what is y cubed?
Y squared.
Awesome. How do we know this? From exponential rules. Good. I go back, distribute to both, and what do I get?
Y cubed.
But I have to write negative, the opposite. Yes, it's negative 2y squared, but I have to write
Positive.
positive 2y squared. See, I have a y squared to write it under. I have a y cubed to write it under. I perform the operations I see. What do I get here?
5y.
Squared. I'll bring down the next in line. Now the next question is, y times what is 5y squared? Y multiplied by what is 5y squared?
Y.
Sign.
Positive.
Yes, we don't lie at the top. So 5y gets distributed to y. What do I get?
5y squared.
Yes. 5y gets distributed to negative 10.
Negative 2.
Gets distributed to negative 2. And negative 10y. I have to write positive 10y. See, I don't have where to write it. So I'm going to write it here. Otherwise, I would have to write it outside and I would have messed up the problem. So that's the key. If there is a missing term, leave room for it. Good. These two go away. I have to copy 10y and I copy 4 again. Y times what is 10y?
Y times
Positive 10.
Yes. Good. So now I go back, bless you. I go back with 10. 10 times y.
10y.
10 times negative 2.
Negative 20.
What do I box in? How do I write the final answer? So let me copy this. Y to the third, 3y squared plus 4 over y minus 2. Please tell me what to write.
Y squared plus 5y plus 10 plus 24 over y minus 2.
Here's a question. I have doubts about my work. How do I check my work? And let me just show you a simple example. 10 divided by 3, would you agree, is 3 plus 1/3?
No.
3 times 3 plus 1 is 10. 3 times 3 plus 1 is 10, because this is 9 over 3. 9 over 3, which is 3, plus 1 over 3 is 10 over 3. Agreed? Yes? This is 9 over 3, plus 1 over 3. Is this 10 over 3?
Yes.
And 9 over 3 is 3.
Oh, got it.
So 3 times 3 plus 1 is 10. How will I check this? That's your hint. Three times 3 plus 1 to check the 10. Y minus 2 times
The trinomial
exactly plus
plus 24.
should equal
That.
exactly. If it doesn't, I made an error somewhere. One more time. 3 times 3 plus 1 is 10. So if I show that y minus 2 multiplied by y squared plus 5y plus 10 and outside plus 24 equals this, then the correct division was performed, or the correct answer is clear there. So let's distribute. I cannot use any special product here. I have to distribute. Y times y squared is y cubed. Y times 5y, 5y squared. Y times 10, 10y minus 2y squared minus 10y minus 20 and plus 24. Y cubed? Yes. 5y squared with negative 2y squared? Yes. 10y with negative 10y? Yes. 24 minus 20? Yes. So this is the correct answer. I checked. How do you remember this idea? It's from my simple example here. 3 times 3 plus 1. This times this plus 24 has to equal the top. Okay, we have time for at least one more. I know it's very cold. I don't know what's happening with this room. I know, I'm so sorry. Okay, so let's choose 57. Please bring a blanket next time. Something. Okay, 50. I said 57? Or what did I say? 57. Okay. X to the 5th plus x squared over x squared plus x. This is not an easy situation. I have to warn you from the beginning. Okay, I use a long division, correct? Good. Are both in descending order?
Yes.
Good. What is the degree of, I don't care about the degree of the bottom. But what is the degree of the top? 5. Top is 5. So is there a 5th degree? It has to be. Is there a 4th degree?
No.
No. Is there a 3rd degree?
No.
Is there a squared degree? Or 2?
Yes.
Is there a 1st degree? Is there a degree 0?
No.
Okay, so 2 terms are missing here and 2 terms are missing here. X squared plus x. X squared multiplied by what is x to the 5th?
Next to the third.
Very good. I go and distribute. X cubed times x squared.
Next to the fifth.
X cubed times x.
Next to the fourth.
X squared times what is negative x to the fourth?
Negative x squared.
Very good. Go back and distribute. Negative x squared times x squared. It's negative x to the fourth. Negative x squared times x.
Negative x to the third.
See how important the space was? Because I wouldn't have been able to put an x to the fourth anywhere or x to the third anywhere. X squared times what is x cubed? Very good. Go back with x and distribute. X times x squared. Yes. Subtract. X times x.
X squared.
Subtract. What do I box in?
Nothing.
Exactly. Nothing. So, what is the final simplified form and final answer?
0.
This is the remainder.
Negative x
How does
squared
it?
plus x. And negative.
X cubed
Oh,
minus
X
It was a different color thing.
plus x. If you want, we don't write that. I just want to emphasize. Since this is 0, there is no need. So what do we conclude? That this binomial is what for this binomial, since the remainder is 0. So, say it again. Nope. Is 10 divisible by 3? No, because there is a remainder. Is 9 divisible by 3? Because there is no remainder. So what word do we use to qualify 3 for 9 versus 3 for 10? We say that 3 is a,
Factor.
thank you. 3 is a factor of 9. Final question for you, and I'll stop. What can I say now about this polynomial for this polynomial since the remainder is 0? Exactly. X squared plus x is a factor of the polynomial x to the 5th plus x squared. Why? Because when I divide it, I got remainder 0.